Today we're going to be looking at sort of a preview of our next unit. We're going to look more at simplifying rational expressions and different rational expressions in Unit 4, but for now we're going to focus on how can we simplify these expressions by factoring. And so we've already sort of talked about what rational means. Remember, it has this root ratio, and so you can think of it as our fancy math word for fraction. So rational expressions are a fraction, where we have a numerator and denominator. And so we actually saw some of these in our last notes, where we had f divided by g of x, and we were dividing functions. And so what we want to know is, can we simplify our result? And so let's review some old stuff. How do we just simplify fractions in general? So if we want to simplify fractions, basically what we want to do is cancel out common factors. And just a quick reminder, remember, cancel when we're talking about multiplication or division is 1 and not 0. So if everything cancels, then it's equal to 1. It's not equal to 0. That's a common mistake we make. So let's look at two examples of sort of earlier simplification we do, because we simplify rationals a lot. If we just have numbers like 64 and 14, then what we're really doing when we simplify these is factoring 64 and 16. And so if we know our factors, or we can use our calculator, 64 is 8 times 8, and 16 is 8 times 2, then we can cancel out these 8s, and then we're left with 8 and 2, and so we can factor 8 is 4 times 2, and then we would cancel these out, and what we really end up with on the bottom is a 1. And 4 divided by 1, we don't really need that divide, so we would get 4. So 64 divided by 16 should simplify to 4. We can check that. 64 divided by 16 gives us 4. One of the nice things about Desmos is if we have a different one, like 52 divided by, let's say, 18. That's not so nice, but if you click this little button right here, it will actually give you the simplified fraction. So Desmos will actually help you do this. Let's do another example. What if we have a variable? And we know how to do this, right? So we're going to do the same type of thing. Let's factor 54. Well, that's 9 times 6, and x squared is x times x. This is what that whole thing looks like. On the bottom we have 72, which is 9 times 8, and then we have 4 x's. And you don't necessarily have to write this out. Maybe you saw different factors. It doesn't matter. 9 and 9 cancel, and then both x's cancel, but we're left with 2 on the bottom. Another way we can do that is to subtract these exponents, and we get a negative 2, which means we're going to end up on the bottom. And we'll review negative exponents in Unit 4. So once we cancel those guys out, we're left with a 6 on top, and that's it, an 8, and 2 x's on the bottom. But we can continue to factor. 6 is 3 times 2, 8 is 4 times 2, we have 2 x's. Those 2's are going to cancel each other out, and we end up with 3 over 4x squared. We don't necessarily write all of these steps out. If you find it helpful, you can, but we're not really required to. But sort of writing them out helps us see how we can do this with polynomials. So we're going to apply those same principles to how do we simplify if we have a polynomial over a polynomial. Well, all we have to do is factor. We just need to make sure that we factor both the numerator and the denominator. So let's try it. In our first one, our numerator is just a number, so we can factor that. 45 is 5 times 9. On the bottom we have a binomial, so this is just going to be a GCF problem. And they have 10 in common. So if we pull a 10 out, we get a minus 1. Remember, we're dividing by 10. And when we divide, cancel means 1 and not 0. So now we can't factor anything the way it stands, but we can't cancel anything the way it stands, but we can factor 10, right? 5 times 9. 10 is 5 times 2. We have a minus 1. And so what we see is that these 5s go away. So we end up with 9 divided by 2, a minus 1. And so we're going to see in our next unit that sometimes it's actually really nice to leave this factored instead of recombining it. So we're going to leave our answer like this. Let's try another one. So this time we have a binomial on the top and bottom. On top we have 2r minus 4, and on the bottom we have r minus 2. So we're going to factor. This is going to be a GCF problem because it's a binomial and it's linear. How do we know it's linear? Well, it's degree 1. So what do they have in common? They have 2 in common. So we're going to pull that to the outside. And what we're left with is r minus 2. On the bottom, r minus 2 can't be factored, but once we get here, we see now that we have an r minus 2 on the top and bottom, and so that whole expression cancels out. And so we have to cancel a whole expression. This 2 doesn't cancel with this 2. Be careful. And so what we're left with is a 2 on top, and remember when we cancel, we're left with a 1, so we get a 1 on bottom, which means that this is really just the same thing as 2. Keep going. So in our next one, we have v minus 5 and we have v squared minus 10v plus 25. You might be tempted to say 5 and 25 cancel. They do not. You cannot do that. This is equivalent to saying 3 plus 4 divided by 2 is equal to 3 plus 2 if we divide 4 by 2, but that's 5. And this is really 7 over 2, which is 3.5. Why doesn't that work? Well, because we're really dividing 3 by 2 and we're dividing 4 by 2. And so when we have that plus sign in the middle, we can't just divide stuff like that. We have to have a multiplication. Like we're doing, we have to have factors to cancel out, not terms. We don't cancel terms, we cancel factors. So our numerator is linear and it has no GCF, so we can't do anything. Here we have a quadratic with the leading coefficient of 1, so let's factor. We're looking for factors of 25 that add up to negative 10. So we negative 5 and negative 5. So factored out, we'd have v minus 5 on top. In the bottom, we have v minus 5 and v minus 5. Now there are 2 on the bottom and 1 on top. Just like up here, where we can only get rid of matching ones, it's the same down here. This v minus 5 on top only gets rid of one other one on the bottom. So we have a v minus 5 on top and a v minus 5 on bottom. They're going to cancel each other out. We're still going to be left with 1. Where is it? It is on the denominator. It needs to stay there. When we cancel, we are left with a 1. So this is going to leave us with 1 divided by v minus 5. Let's do another one. So here we have a quadratic on the top and bottom. They are both quadratic. So let's see if we can't factor them. They both have leading coefficients of 1, which is nice. Let's factor our numerator, or the top. We're looking for factors of 40. That sum up to negative 3. It's going to be negative 8 and positive 5. So on top we get x minus 8, x plus 5. Let's factor our denominator. Let's do that one in orange. So here we want factors of 24 that add up to negative 11. It's going to be negative 8 and negative 3. So our denominator looks like x minus 8, x minus 3. Now we can actually cancel. The number one mistake people make is they go, oh, let's get rid of those x squareds. You cannot do that. You cannot eliminate when they are attached to something with a minus or a plus. We can eliminate now because everybody is attached with a multiplication. So we have to eliminate full factors. So we got to eliminate these two parentheses. They are the same. They will cancel each other out. And so we're going to be left with x plus 5 on the top. We don't need the parentheses anymore because it's alone. And on the bottom, x minus 3. I'm going to say that one more time. You cannot eliminate when things are connected with plus and minuses. You can't do it. We talked about why when we did this little example here. It doesn't work that way. Okay. Let's actually talk about that a little bit more. So what's really happening here, if we wanted to split this up, is we have x squared divided by x squared minus 11x plus 24 minus 3x divided by x squared minus 11x plus 24 minus 40 divided by x squared minus 11x plus 24. And so when we split it up like this, it becomes really clear, hopefully, that that's not going to simplify. Okay. Let's do another one. So here we have a quartic on top and a cubic on the bottom. Quartic. Cubic. So we're going to have to use our new factoring methods. This one is going to be substitution. Let's do our numerator first. So we have 2x to the 4th minus 19x squared plus 9. So let's use g. Let g be x squared, and g squared equals x to the 4th. If we do that, we have 2g squared minus 19g plus 9. This has a leading coefficient that's not 1. Our leading coefficient is 2, so that means we need to do slide and divide, or whatever method you prefer. If you don't do slide and divide, that's fine. But if you do slide and divide, make sure you actually divide. That's where we tend to make our mistake. 2 times 9 is 18. Factors of negative 18 that add up to negative 9, factors of 18 that add up to negative 19 are negative 1 and negative 18. Then we got to make sure we divide. We always divide by our leading coefficient. And then we need to make sure that we simplify. That's another mistake we make sometimes here. This one doesn't simplify, but this guy does. End up with 2g minus 1 and then g minus 9. Now we got to put our original variable back in. This is really 2x squared minus 1, x squared minus 9. This guy is a difference of squares. We can continue to factor. We get 2x squared minus 1, x plus 3, x minus 3. So that's our numerator factor. Let's write it over here. 2x squared minus 1, x plus 3, x minus 3. I'll move it over so it's inside the box. All right, there's our numerator. Let's do our denominator. So this is cubic. It's got 4 terms. This is grouping. So we're going to group them together. 2x cubed plus 6x squared plus negative x minus 3. In our first group, our GCF is 2x squared. When we pull that out, we're left with x plus 3. In our second group, we're going to pull out a negative 1, x plus 3. We got our x plus 3 now as our common binomial. Then we take what's left for our next one, 2x squared minus 1. This is a difference and squares, but 2 is not a perfect square, so we can't factor that at all. So let's put our denominator in. 2x squared minus 1, x plus 3. Once we are factored, we can now cancel out any like factors from the numerator and denominator, and we see that we have these 2x squareds minus 1. They cancel each other out. And we also have x plus 3 on the top and bottom, which cancels, which means the solution is x minus 3. So that big, complicated rational, this whole thing, is really just x minus 3. All right, let's do our last one. So here we have 8x to the 4th minus 27x divided by 4x squared minus 9. So our top one has a degree 4, but it's not a substitution problem because we don't have enough terms. But notice how both of our terms have an x? Let's factor that out. X 8x cubed minus 27. Let's keep our denominator. Once we do this, we have a better idea of what we can do with our numerator. This is a difference of cubes now. So we can do our little SOAP method to factor it. And so let's go ahead and do that. I'll write it over here, 8x cubed minus 27. We'll do our little forks. 8 is really 2 cubed and 27 is 3 cubed. So this is 2x. This is 3. I'm just ignoring the sign in the middle right now because I don't care what it is. Little parentheses, one of each, 2x and a 3. Big parentheses, pair them off. 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 3 is 9. Then we use SOAP to clean it up. S-O-A-P. S is same size as original, it's minus. O is opposite, that's plus. AP is always positive. So it's our numerator, it's going to be x times what we just got. 2x minus 3. Don't forget your GCF, that x out front. And then our 4x squared plus 6x plus 9. All right, let's see what we can do with our denominator. What do we got here? Well, this is a square binomial. 4 and 9 are also squares, so this is a difference of squares. 4 is 2 squared, 9 is 3 squared, and so this is just 2x minus 3, 2x plus 3. Do we have any common factors? We do. 2x minus 3 is on the top and bottom. They're going to cancel each other out to be 1. And so we are left with x and then 4x squared plus 6x plus 9 on the top. And on the bottom we're left with 2x plus 3. And so this one does not simplify all the way down, but it does simplify a little bit. We can cancel that one term. So that's the sort of simplification we're going to be practicing with rationals for this unit.